Hi, everybody. So this is my third video about how to solve systems of linear equations in two variables. So we talked about how to graphically do this and how to do this by substitution. So our last method will be elimination, aka addition method. We call it that because we're essentially trying to eliminate one of these variables by adding these two equations together. Problem is, if your coefficients in front of whichever variable you're trying to get rid of are not additive opposites, meaning they have the same absolute value but different sign, then you cannot add these two equations and get rid of a variable, okay? So kind of remember our purpose here. The reason why we'd want to get rid of a variable by adding the equations together, because we want one equation in one variable, okay? So let's go ahead and show how we would do this. We're going to be bringing up the concept of the LCM again, okay? So LCM, remember that's least common multiple. And we're going to be using that to multiply an entire equation by a value that will get the coefficients in front of your variable to be eliminated to cancel out when added. All right, so let's go over this one. I want you to see that for line 1, the rest of this space, we have 7x minus 3y equals negative 14. And for line 2, we have negative 6x plus 5y equals negative 5. So let's just say we want to eliminate y. And part of the reason for that, look at these numbers. The LCM between 3 and 5 will be lower than the LCM between 7 and 6. So you're going to be working with lower numbers throughout the problem, which is typically a bit easier. Okay, so I'm going to eliminate y. So I'm going to emphasize that's my choice. Okay, I could eliminate x if I wanted. All right, so what I want you to do is think about the LCM between 3 and 5. Okay, we don't care about the negative and positive right now. We'll see how that comes into play soon. But go ahead and review your LCM knowledge. Between 3 and 5, you get 15 as your LCM. So here's what we do. We say, okay, if I'm looking at the 3 here, and I want to multiply this 3 by something to get 15, what would I need to multiply by? Oh, well, I need to multiply by 5. Okay, so I'm going to multiply that 5 not only to the term with 3 in it, but also to all the other terms. Okay. Down here for line 2, we have a 5 here. We want a 15, so we're going to multiply by 3. Same thing, we're not going to multiply the 3 just to the 5. We're going to multiply it to the coefficients for every term in the equation. So now this is when we look at the sign in the front. Okay. If I multiply the 5 to a negative 3, I get a negative 15. If I multiply 3 to a positive 5, I get a positive 15. We'll see in a second that those are additive opposites, so that's perfect. Okay. Distribute instead. So line 1 now looks like 35x minus 15y equals negative 70. Never been the hottest with arithmetic. My downfall. All right, now for line 2, negative 18x plus 15y equals negative 15. Notice, if I try to add the equations, I want to see, am I going to zero out, okay? Am I going to zero out the variable of my choice? I see that I have a negative 15y plus a positive 15y, which gives me 0y, which turns into 0, just cancels. So here, we're going to add, same thing over here, 35 minus 18. That's going to give us 17. Don't forget you still have an x attached, like term. And that's going to equal negative 85. Okay, so we wind up, when we divide by 17 on both sides, getting negative 5 for our x value. And box that. Okay, and then similar to substitution, now we must back substitute x into L1 or L2 to solve for 1. Okay. So we eliminated one variable of our choice by adding the equations together. We have an equation in one variable now that we can solve. Go back, substitute into one of these equations. I will use line 2 because the numbers, the coefficients are smaller. So line 2, I have x is negative 5. So negative 6 times negative 5 plus 5y equals negative 5. That's 30 plus 5y equals negative 5. Subtract 30 from both sides. And then divide both sides by 5. So now we have a y value. Once you have your x and your y, you're ready to plug them in. Then check that, and we're good to go. All right, so hopefully that will help you guys to understand how to solve a system of linear equations in two variables. We had the graphical method, we had substitution method, and now elimination addition method is complete. So in my next video, I will go over some word problems with you guys, and I will also go over how to figure out if a system has no solution or infinitely many solutions using substitution and elimination. See you next time.